So hope you had a good coffee break after a day of soul-stirring talks. So I promise you I won't bore you much here. So today this talk is going to be about BigPetStore Flink. It's a comprehensive blueprint for Apache Flink ecosystem. So before I go further, a little bit about myself. I work for Red Hat. I'm a principal engineer in the Office of Technology. And I'm a committer and PMC member on Apache Mahout. And we had a very good session about Apache Mahout, linear algebra Samsara DSL library this morning from Sebastian. I'm sure most of you found it useful. And we do have Flink and Mahout bindings coming in soon in the next release. And I'm also a contributor to Deep Learning for J and Oryx 2.0. And this is a project I worked with Sean Owen from Cloudera, Oryx 2.0. And Deep Learning for J is from SkyMind. And I'm also the co-organizer of Washington, DC Apache Flink meetup. And we do have a very strong membership in the meetup. And it's been only 2 months since we started the Washington, DC chapter of Apache Flink. And we already have 200 members signed up. And we have a second meetup coming up next month in November. And I'm the founder of the Boston Apache Flink meetup group, too. So, BigPetStore. So all of you have heard about PetStore, BigPetStore applications, right? And this goes back to the old days of Java J2E when we had the J2E blueprints for BigPetStore and the design patterns for J2E, how to best apply J2E for web applications and enterprise applications. So what is a BigPetStore, and why do we need a BigPetStore? What is synthetic data? And what are the different BigPetStore applications we have today that have been implemented? And what are the future possibilities that can be done? So what is BigPetStore? It's kind of a blueprint for big data applications. And BigPetStore is a part of the Apache Bigtop project. And this was done by 2 of my colleagues. It was started out by 2 of my colleagues from Red Hat, Arjen Oling and Jay Vyas. And it's now part of the Apache Bigtop project. Initially, it was done as part of Bigtop to sniff out the MapReduce, to see how MapReduce scales, how it works, not with a word count, but with a real data generator, with real data loads. And it consists of different data generators for different types of data, and we'll come to that. And it also has examples. So if you can, it has an example for running MapReduce, for testing Hive, Pig, and it also has an interface with Mahout for testing Mahout algorithms. And it also consists of a build system for integration testing. So you can look at your CI server and see how many tests are failing and using the BigPetStore data generators. So it's part of the Bigtop project. And it's got some examples of how you can write a custom Bigtop application with BigPetStore. And we have some demos and benchmarking against, so we have the benchmarks of MapReduce versus Spark versus Pig versus Hive, and the different big data frameworks using the same data. So why do I need a BigPetStore? As a developer, I cannot rely on word count. So when I first started out learning MapReduce, the first example I was introduced to was word count. Oh, great, so I understand what MapReduce is. I know how to write a MapReduce job. Then on my real job, I had 2 gigs of DNS traffic data, which I was asked to analyze. And then the issues came up, OK, so most of the data is going to one partition to one mapper only. And the mapper is taking forever to complete, and the other mappers are done long before this mapper done. OK, so the word count is not a good example for a real-life application. So what is the other way around? We need to have some real data generators which can generate data at load and which can kind of mimic or simulate the real data that you see in production. So as a developer, you want to have real data that you want to work with to test your algorithms and to test your big data frameworks. So word count was great for a MapReduce introduction, but it does not, real life examples are not word count examples. So pet stores have been around for a while now. The first pet store was the Java J2E pet store in the early 2000s when the J2E specification was published by Sun Microsystems. And then we had Microsoft, which came up with an alternative pet store called Pet Application using .NET Framework. And they benchmarked the Pet Application with .NET Framework against the J2E pet store. And they kind of said, OK, .NET is better than J2E for the performance-wise and for scalability. So then Sun Microsystems again went back and said, OK, fine. let's go with a different framework. So I think this is where it's taking most of the time in our PetStore application. This is where we're spending most of the time in trying to crunch the data. So this is where we can optimize things. So it kind of tells you where the choke points are in your application and where you need to optimize. But we never saw a big data PetStore. So when Hadoop was published and when all that we had was a word count example to start with. So nobody ever thought about a big data PetStore. And the big data PetStore is kind of a vision that we had at Red Hat, two of my colleagues who started out on this project. And this is part of the Bigtop, Apache Bigtop. And we have data generators for different sets of data. So you have the names database, you have the customers, you should be able to simulate transactions, you create the stores, and you have the stores in part of a specific geolocation, and you have customers living in a different geolocation. So what is the nearest store to this particular customer who is living in this geolocation? So all that kind of data which we generate. And we have different algorithms for generating those data. We use Markov models. We also use multinomial regression for some other data stuff. And the idea is to build more sophisticated blueprints for sniffing out your applications and your infrastructure and your scalability than a simple word count. So this is what we call synthetic data. So what is synthetic data? So in order to integrate your frameworks with in order to have some integration tests and unit tests, you cannot use the real data sets because real data sets are sitting in a production environment and they're completely logged out and they're in a private environment. And how do you simulate data which closely mimics the real data sets that you have in production? So that is what we call synthetic data. So, and also you have the licensing concerns that you got to deal with. And so if I want to do a TerraSort on my real data, production data, I cannot do that directly. So I need to generate a synthetic data set which mimics the production data set and run my TerraSort on that. So in the Bigtop, we have a project called Bigtop Data Generators. It is part of the Bigtop umbrella. The idea is now that we are seeing adoption across different Apache projects. It started off with Bigtop, but I see that we can use it for Mahout for testing out Mahout algorithms, as well as we also have an integration with Spark to see the Spark's performance, Spark SQL performance, and Spark streaming performance. So we have different data generators. The first one is it's a BigPetStore data generator. The BigPetStore data generator generates the customers, and the customers are generated based on the names database that we have from the US Census Bureau. And we use the zip code location database for generate the zip codes for the customers. And then we also generate transactions. Transactions would be like, OK, this customer bought dog food, and this customer bought cat food, and this is the number of times he bought cat food in the given specific time period. So what is the likelihood that he's going to go back to the same store again 2 weeks down the line to buy a similar item? So you can also kind of build recommenders around this BigPetStore application. So we have a Bigtop Weatherman. This Bigtop Weatherman is still experimental. It's basically, we have the weather database, and we are trying to simulate weather data, trying to generate weather data for being able to predict what's going to be the weather like in the future, for kind of doing some predictive analytics around it. And we have the locations. Locations is basically the zip code, and we have the names generator, which is basically from the US Census Bureau names database. So what's presently in Bigtop is we have the Bigtop MapReduce, which is already well integrated into the Bigtop project, and that's the Jira Bigtop 1270. And it's basically a MapReduce application that was created originally to demonstrate MapReduce, Pig, and Mahout. And the data generator back then was hierarchical. It was a very primitive data generator. We were not using Markov models. It was purely I would say, OK, so this customer and this location, it was based on random heuristics. And and we have been using this BigPetStore data generators at Red Hat itself for sniffing out networks. And whenever we have a cluster upgrade, we are able to troubleshoot, OK, what are the issues that we have when we do a cluster upgrade? And we had seen tests that had failed when we did a cluster upgrade, thanks to the BigPetStore applications. So now we have a more new data generator, and we have a more modern data generator than what we had earlier. And the big motivation for this being that most of the big applications that we have seen in the big data space are based around analytics and machine learning. And as a Mahout committer, one of the big issues that we had always seen was we never had the real data to sniff out our algorithms and see how our algorithms perform. And then when I came across this project in Bigtop, I said, OK, wow, this is cool. This is what we have been missing all the while. And we are actually working on integrating down the BigPetStore and the big data generators into the Mahout project itself. And now the new data generators are based on mathematical modeling. So we are using hidden Markov models for generating the customers and their purchases and the zip and the areas where they go and the stores they go to purchase. And the sampling, we are using Poisson process for sampling. So how often does a customer go to a specific store in a specific zip code? So we kind of do a Poisson sampling around that. And for generating the transactions or for simulating the transaction would be that this person bought dog food in this particular store on so-and-so date. So we have some stochastic differential equations which would simulate that kind of a data and generate that kind of transactions. And the transactions is the big thing in the BigPetStore application, since the transactions is what, based on the transactions, you can build recommenders, more realistic recommenders targeted towards different customers, and also recommend products to customers based on their past purchases. Right now, we are working on building a platform-independent data generator. So when I say platform-independent, some of our data generators are very tightly bound to Spark, and they are tightly bound to Spark and to MapReduce. So based on the experiences of what we have learned as part of Mahout, trying to build a platform-agnostic linear algebra library, we're trying to take the same lessons learned and apply it to the BigPetStore data generators too. So trying to build a big data generator which is agnostic to Spark or Flink or MapReduce and H2O. So this diagram here is an overview of what are the different transaction purchases, which is based on a hidden Markov model, and how the data is generated. So you have a customer. It's a customer simulation state. And so when the customer goes to make a purchase, you start, OK, this is the start of a purchase, and we got to simulate a purchase and a transaction. So the customer goes to a specific store. OK, which store does he go to? So the customer's geolocation is 1, 2, 3, 4. So what is a store that is closest to this particular location? So you calculate the Euclidean distance of the other zip code stores, and then pick the one that is closest to this particular customer. So the likelihood that this customer is going to go to this particular store in this particular zip code is higher than as opposed to the other zip codes and other stores. And OK, so then the customer goes to purchase dog food. OK, so dog food, he purchased dog food. And then you kind of generate a Markov model around it. OK, dog food, and then how likely did he come back to the same store to purchase dog food? And then you have the other customers who are purchasing something similar items in the same store. Then the Markov model generates recommenders, saying that, OK, this customer bought so-and-so thing on so-and-so date at this store. Other customers who had been to the same store bought different things, had similar purchases. Then you kind of build a recommender system around that, saying that these are the similar purchases. Based on your purchases, this is what the others have purchased, and this is what we would recommend to you. So this is a graphic of the customers closest stores. So how likely are they going to go to the stores which are closest to them? So the distance in miles versus the customers, the count of all the customers who have been visiting those stores. It's a graphic of that. And what are the purchasing habits of the customers? So for example, if somebody is buying dog food, is he buying the same flavor? How often does he buy the same brand or the same flavor? And at what time intervals is he buying that? So this is the kind of sampling we do when you generate the data. This is a generative data model leveraging hidden Markov models and, sorry. So this is a generative data model leveraging hidden Markov models and mathematical modeling techniques. And we are using the mathematical techniques to simulate the customer's purchases. Right now, it's hidden Markov models, but there is work underway to move from hidden Markov models to using a multinomial regression. So it's kind of a hierarchy. You have the Markov model at the top, and then you have a multinomial regression one level below to simulate the customer's purchases. So we're trying to see which generates better data, the hidden Markov models that we have now and the new one that we're trying out. It's kind of an experiment we're working on. And based on that, you can actually parameterize your machine learning models. So based on your purchases and the kind of data that you're generating, you can parameterize your machine learning models. So this is a sample schema of the different data points that you have in the BigPetStore data generator. So you have a transaction. The transaction has got a customer and the transaction ID, and the store ID, that's where you went to make a purchase, and the time when you made the purchase. So the store is basically the store ID and the zip code. So each zip code would have a store ID. And the customer, you have a customer ID and you have a name, and the name is generated from the names database, which from the US Census Bureau. And the zip code is from the US Postal Code's zip code locations. And the transaction consists of a customer ID and the transaction ID and the item that he purchased, whether it's a dog food or a cat food or dog poop. That's one of the items. So this is the data model that we have, and now the data, we generate data based on this model. So the transactions is one of the big thing that's got everything based on all the purchases and the transactions. You can actually do a lot of realistic analytics on the transactions itself. And now we have used this to test out different infrastructure issues. So what you're seeing here is a Docker. We are actually running this in a Docker container to see how the Docker behaves when you run with the real data that's generated, with the big data generator. So there's no need of an API calls. We can generate load for any application. So you can specify the number of stores you want to include as part of your simulation, the number of customers, and the frequency of transactions, and how often does a customer go to a specific store in a given zip code. So all of those parameters can be parameterized, and these are the different knobs you can turn for generating your data. So we have a BigPetStore Spark that's already part of it, and one of my colleagues, Ajay Noling, he's the one who's worked on the BigPetStore Spark. You have integration with Spark SQL and the Spark Core and Spark Streaming today, and we are actually using Spark SQL for some of the ETL stuff for that. And we already had a BigPetStore MapReduce integration. It's been there with the old data generators. So now we have been working for the last 1 month. We have been working on the BigPetStore Flink. And we kind of see this, the reason for this is, there's been a request from AWS to integrate Flink as part of Apache Bigtop. And so there is a demand from the Bigtop community to have Flink as part of their distribution. And we thought, okay, when you integrate Flink into Bigtop and we keep having Bigtop releases, how do you sniff out Flink and see how it's performing? So then the idea came, okay, we have the BigPetStore application, which is already there in place for Spark and MapReduce. So I think we should also integrate that with Flink, and that would be a good sniff test for Flink itself. And this is something that Flink could use for the Flink ML project as part of the data generation for testing out Flink ML algorithms. So we have an initial implementation that's using Flink streams to generate data, and the generated data is returned to the disk. And then we have a downstream process, which is a data transformation process. It reads the generated data from Flink streaming, and then does a data transformation on that, and it transforms the data and build a recommender around the purchases based on the simulated data. And those are the Bigtop JIRAs, 1927 and 1928. That's currently in place to track this integration. So this is some of the sample code from BigPetStore Flink. So this is basically generating the transactions. So we are using Flink streaming, data stream APIs. We are using data Flink 0.9, and I think the 0.10 was released on Saturday before I took my flight to here. Sorry?
It's not released yet, but when it's going to be released, it's going to break a little bit the API you're using here.
Okay. So this is basically, if you look at this code here, we are generating a transaction, a list of transactions for a given customer. So let's see. Oh, shoot. So we're generating a list of transactions for a given customer. And so the input to this is a customer record. And the customer record, as we had seen from one of the earlier slides, is basically a customer ID and a name and a zip code for the customer. And then, based on that, we generate the product categories. So what are the different product categories for this particular customer that we can assign to? So product categories could be like dog food, cat food, dog snack, or a cat snack, or dog poop. And, and then you generate a purchasing profile for this specific customer. We generate a purchasing profile. Purchasing profile is basically, you have a seed factor that you can initialize. Okay, how often do you expect the customer to go back and purchase the same item from the same given store? And then based on that, you generate some purchasing profile data. And then you generate transactions. You generate the transactions from these purchasing profiles on the stores and the products that he bought. And this transaction data is what we use for downstream ETL processing and analytics. So in the future, what we plan on building is, we would like, number one, right now there's a lot of boilerplate code in the Bigtop data generators, partly because we have our own code for generating Markov models for random sampling and different sampling techniques. And now that we have probabilistic programming languages in place, like Figaro for Scala, and there's one for Clojure too, I can't recall what it is. So it's going to save a lot of the boilerplate code that we have, and we can reduce the code size to much smaller and more manageable size. And how do we produce synthetic copies from the real data sets? So we are generating some synthetic copies from the real data sets right now, but the correlation from the actual data set to what is being generated is still there's a gap. And that's the gap we are trying to fill and see how we can do it. And apparently there have been some papers that have been published recently about being able to generate synthetic data sets that are more realistic in nature. We are also investigating probabilistic programming languages like Figaro for sampling. So right now we have all the boilerplate code for sampling and inference, for Bayesian inference and for multinomial inference. So if we could use the programming languages that already have it, then it's going to reduce most of our code. And also provide a high-level DSL for similar to what we have in Mahout for the users to be able to generate data and see how the data and use it for analytics downstream. And of course, the big thing is we want to be able to use this Bigtop data generators for doing real-time load testing, for real load testing scenarios. And this is something that we had started out on internally at Red Hat. We have used it for some of our internal cluster load testings. Right now, we have only a Flink streaming blueprint in place. And the future, we would like to add a Flink batch API as part of it, and Flink table API when it is available and when it's alpha, and Flink ML algorithms. So I do see that Flink ML is using specific data generators that have been written in-house. So I think you could leverage these data generators for sniffing out your algorithms. And some of the resources that we have, this is a paper that is published by my colleagues, Jay Vyas and Ronald Norling. And that's around the Bigtop data generators and BigPetStore. And the code for this is part of the Bigtop GitHub project. That's the Bigtop data generators, and the BigPetStore code is here. The BigPetStore code has a single-page web application UI for actually looking at actual purchases and transactions. It's kind of a nice UI interface. And if you want to include the Bigtop data generators as a library in your project, it's available here from Bintray. So TLDR. So we would like to see this, given the response we had from the Apache community for this Bigtop data generators. As a Mahout committer, I see it being useful for the Mahout project. And we have had people from the other Bigtop projects like Flume and what else? Flume and a few other projects and Deep Learning for J, who are interested in this Bigtop data generators. And this is going to save them a ton of code, which they don't have to write in-house. And so based on the feedback that we have, and given how useful this is going to be across the various Apache projects, and not specifically to Bigtop itself, the idea is to spawn this off and spin this off as a separate Apache project in the future. And right now, it's residing under the Bigtop umbrella, but in the future, we would like to spin this off as a project of its own. And having comprehensive blueprints for all the different big data frameworks. So we have MapReduce, Flink, MapReduce, Spark streaming, and Flink streaming in place now. In the future, we would be adding Flink batch and Flink ML and Flink SQL when it's ready. So the Flink-based BigPetStore would soon be part of the Apache Bigtop distribution in the next release, or maybe in the next release. And of course, as we have new Flink features coming in, we'll be expanding the application to accommodate all the new features that have been put in Flink. And the big thing is we would like to make it easier to build models. the data models that we have, we would like to make it much easier. So part of how to make it easier is, part of that is based on using probabilistic programming languages, as I mentioned in the previous slide. And that would reduce a lot of the boilerplate code that we have. And the APIs are still being polished out based on the user feedback and experiences that people have had with it. And based on the new research papers that have been out, we would like to modify the data generators to generate synthetic data that more closely mimics the real production data that we have. Questions on this?
So you have mentioned that you would like to make your data generators framework agnostic. And I know that basically one of the things that you can use for this is this neat Java library. But when you actually want to generate big data, you usually use a framework, be it Spark or Flink or some framework that does the data generation in a parallel fashion.
Yeah.
Do you have plans to do some in-house solution on the Bigtop side for that you can do some parallel data generation, or you will always rely on one of these frameworks?
So the idea is to kind of do what Mahout has been doing with the linear algebra DSL, which is kind of agnostic to the underlying engine, whether it's Spark or Flink or H2O. So that's a lesson we learned from the Mahout experience, and we can utilize that experience here and in the Bigtop big data generators too. And that's where we are going with this, to answer your question.
So have you actually done any comparative studies across these different frameworks that you can talk about, that you'd like to talk about?
Yeah, we did, but I'm kind of a bit hesitant to talk about it. So,
why is that?
why is that? Because I guess it's not a thorough comprehensive study yet, and we have a very initial results. It's not something that we could publish yet. And Flink streaming is something that we have just started playing around with it. So compare Flink streaming with Spark streaming is something we're looking at doing down the line. And once we have this integrated as part of Bigtop, yes, you can compare Flink streaming and Spark streaming on the same generated data sets or the same load on the same clusters and see what the numbers are. And that's the idea in the long term. And of course, Flink is well known for the streaming as opposed to Spark, which is a batch, which is a mini batch. And so we would like to see the mini batch versus actual real streaming. What are the differences, and what,
Do you have anything in mind or already have that will do failure testing as part of that? Is some like chaos monkey stuff going on in these same projects in order to like evaluate?
no, we haven't thought about it, but definitely that's something we could consider. Yeah. So right now the focus is more right now on making this Bigtop data generators more usable, and based on the demand, we would like to spin this off as a project by itself under the Apache umbrella. Yeah. But that's definitely something that we could look at. Yeah.
Hi. So when Bigtop came out, there wasn't much around the whole area of automated installation, and you guys seem to bet a lot on Puppet, and now we have the worst balkanization of Puppet, Chef, Kubernetes.
Yeah.
And part of Bigtop's role was to help automate the installation of Hadoop environments. Is that still part of your role? And what way do you see on all the different automated installation platforms?
I think Bigtop does have integration with Kubernetes. They do have Kubernetes today. We have a Kubernetes BigPetStore right now as part of Bigtop. And I'm not a Bigtop committer myself, and I'm just working on this Flink BigPetStore integration into Bigtop. That's a question that's more appropriate for one of the Bigtop guys. But from what I know, and following the Bigtop mailing list, and they do have integrations with Puppet and Chef today, and Kubernetes is there in place already. So does that? So
you support them all?
We support them all today, but how effective is it? I'm not sure.
Okay, thanks.
Yeah, hi. I have a related question. Are you aware of any efforts to also integrate Flink with this installation support that Bigtop offers?
Yes, that's part of it. And once we have this BigPetStore integrated into Bigtop, Bigtop is also going to sniff out Flink installation on clusters. Yes. and that's definitely part of it. And as Red Hat itself, we're also looking at integrating Flink with OpenStack Sahara, and being able to deploy Flink, set up Flink clusters using Sahara, OpenStack. Any more questions? Okay. Thank you.